Hey everyone, today is the day. The new features and the new OpenAI library is announced today. Today is November 6th. We are going to go over every new feature and take a look at them with code examples. As you know, I'm building the Everything GPT API course over time. Link will be in the description. This is available to patrons. All the files here will be available there as well, along with a video for each file. We're going to start with the GPT-4 Turbo Basics. Then move on to function calling, take a look at the image generation API, and then the GPT-4 Vision API, both using images from URLs and local images. Then we're going to take a look at text-to-speech, and also we're going to look at the streaming version of the text-to-speech, which streams audio directly from the API as it is being generated. And then we're going to look at basic implementations of the new Assistance API. So let's just begin. Let's start with how we are making our simple call. We're going to use GPT-4 1106 preview. But as you see now, there are some differences on how we use the library. We are going to update our library, right? There's a new OpenAI library, version 1.1.1. At the time of this recording, we will pip install OpenAI - upgrade and upgrade our package. After that, as you see, there are some key differences. We are importing this OpenAI class from OpenAI. And we are instantiating a client from that class, and we pass in the API key. As we normally would, we are importing OS and getting it either from our environment variables, or you can just simply enter your API key here. So this line instantiates your OpenAI client. You can still just import OpenAI, and instead of client, use OpenAI, but this is the convention that is recommended in the documentation. After which time, everything else remains the same, except as you see, now we can access the attributes like the choices and the messages and the content, not as keys, but as attributes, because now the response object is a Pydantic object, which we can use JSON with. And we can actually turn this object into a JSON or a dictionary. But this is it. This is how this part works. Streaming remains the same, except we are again setting the stream to true. Okay, and one other difference I forgot to mention is that we no longer use chat completions together. We do use client.chat.completions.create. Just be mindful of that. And our messaging schema remains the same. So when we're looping, because we set streaming true, we're going to get a generator object. So when we're looping over the response, again, we are using the attributes to access the elements, .choices, .delta, .content, not the keys. And when you're doing streaming, and if you were to actually print each one of these chunks, you will see that the first first content of the delta will be empty, and the last one will be none. That's why we have a simple conditional to make sure that this actually is neither empty nor none. After that, we just grab the content and we print that with and flush parameter arguments so that we can get the streaming response printed in our terminal. Now, another caveat is that because this is a Pydantic object, text chunk is not a string, so we couldn't just append it to our empty string, which we have initialized here, right? That's why we are using the string ahead of it, convert it into a string, and then add it to responses, so that if this were to be a function, you can do whatever you like with this responses, return it or whatnot. Now, I'm not going to be running these in real time because, well, okay, this actually ran because the new model only has, it's a preview model, and you only have 100 usage limit per day, and I actually hit it. Well, this time it worked, but if it stops working, I'm just going to talk about the code. Unfortunately, I do want to cover everything that is exciting, such as the JSON mode. So we can now force the new model to return absolutely correct and parsable JSON objects with the response format parameter. Now, this doesn't guarantee that it's going to be of high quality or it's going to be in the exact same JSON structure that you're looking for. But at least you are now guaranteed, I believe, that you're going to have perfect parsable JSON objects. If you use response format, set the type JSON object, okay? Both of them are strings. Also, another requirement is that you do mention JSON. You do instruct in the system message that the model return a JSON formatted object. If you don't have JSON, I believe in capital letters, I'm not sure if it has to be capital, then you're going to receive an error. From the API, you do have to mention JSON along with response format. Here we are asking for these numbers 2, 3, 4, 5, 6 to be organized into a JSON object by odd and even. And then, as you see, once we receive the response, we are actually loading it with JSON.load. So we have a JSON object. Now we can actually print the response and print the odd and even keys. And this is what I was talking about. I have hit my rate limit. So I will try to cover as much ground as possible without running the code. Every once in a while, it still lets me get a response. So we'll see. Let's move on to the seed parameter. So I have actually tested this. So when we call client.chat.completions.create, now we also have a seed parameter. This can be any integer value you like. And I have actually tested this by asking it to pick a number between 1 and 100. If you keep using the same seed, you keep getting the same response. I've tested it with 1, 2, and 3, and each time I was getting a different response. So this is how the seed works. Next, let's move on to function calling. With function calling, what's new is that the API is now able to call multiple functions in parallel. We're going to talk about this, but like I said, all the code files here, along with their individual video explanation, within which I was able to run responses because I hadn't hit my rate limit yet, is available at Patreon. Link will be in the description, along with the older OpenAI library basics and some more chapters about that as well. Anyway, so we do define a function here. It's a dummy function. It just returns dummy JSON objects, right? So if it's Tokyo, returns this. If it's San Francisco, returns this. If it's anything else, if the location is anything else, return this object. And then we define a run conversation with this message. What's the weather like in San Francisco, Tokyo, and Paris? And we are defining our function as we normally would. But the one thing that has changed is that we no longer have functions, but now we have tools. This new library, when you update it to 1.1.1 and future, will no longer have the functions. Instead, you will have tools, but your function definition schema remains the same. After that, we are going to get a response from OpenAI.chat.completions.create. See, as you see here, in this case, we haven't instantiated the OpenAI object. You can still do this. Okay, we've given it tools, and tool choice auto. Remember, with function, so this parameter before it was called function underscore call, and it could have been auto and object, which signifies the name of the function you want to force API to call, or none, right? If it was none, then the API was responding with regular content. So, but nevertheless, those things remain the same, except the tool choice. The name of the function underscore call has been changed to tool underscore choice. And we do get the message. Response message is this message, and then we look for the tool calls, .tool calls. So it is a key in it, attribute that's called tool calls. And we check if the model wanted to call a tool call. So if tool calls is not empty, if there is tool calls, then we know we're going to call a function. And then we set our available function array just like this, so that we can actually call it when necessary. Remember, we have defined it right here. Okay, moving on. We do append this message, extend the conversation with assistance reply. Okay, after that, we need the info for each function call. So this is the part that is different. So normally when we were doing this before, we were getting a single function call. So we were still doing something similar, but now the tool calls can be a list. That's why we loop over for tool call in tool calls. Then we get its name, tool call.function.name. And then we now know which function to call. But remember, this is within a loop. We only have a single function. So whatever the name is going to correspond to get current weather, because we have defined it here in the function definition. And then we are going to load the arguments with JSON.load, tool call.function.arguments. See, as you see, you no longer have to specify them as keys, but as attributes, because it's a pydantic object. So OpenAI says that now each JSON that is returned, whether you're using function calling or with the JSON mode forced, is going to be a perfectly parsable object, which is really significant, because this was causing a lot of trouble and almost making function calling a little bit useless in some cases, especially in the aspect of programming. But anyway, so we can now rest easy and know that JSON.loads will load our argument. Okay, and then we just simply print it, and then we get the function response with the function to call, location. We get the argument from function arguments, location, and the unit, because that is what this get current weather takes in. So once we have that function response, now we called our function. We are now going to append the function response, function call response, appending it as the tool call ID. So tool call has an ID attribute. So we insert it here. Role is now a tool. Name is the function name, and content is whatever the function has returned. But remember that we're doing this for all three. Okay. So because we are asking, what is the weather like in San Francisco, Tokyo, and Paris when you run this? Let's actually see if I can run it so we can see. Yeah, here we go. Actually, I was able to run it. So as you can see at the end, I'm actually printing these. Well, let me continue right here. So then we get a second response, right? So we send our first response, and then we've sent in the function call response back to the GPT, and then we get our second response, and then we print that because that's what this is returning. So let's take a look. So we are printing each tool call, which is an object, chat completions message tool call, which is an ID, function object, which is arguments, right? Location San Francisco. This is the name of the function, and it's the type of function, and it has done that 3 times, one for San Francisco, one for Tokyo, one for Paris. So our single API call was able to return 3 tool calls or function calls. So that's the important part. And after that, we are getting the second message. San Francisco is the temperature, Tokyo, because what happened here is that once our function calls were executed, we got these JSON objects from the current weather function, and we sent it back to GPT so we can get an answer in natural language, and that's what we did here, right? The current weather in San Francisco, Tokyo, and Paris. Yeah, so this is in a nutshell what is different with function calling. It's made easier by the introduction of responses being pydantic objects and the fact that JSON is now absolutely parsable. Now let's move on to the image generation. Like I said before, all these code files along with their individual video explanation will be available at Patreon. Link will be in the description. So this is now Dall-E-3 is available. And again, we import the OpenAI from OpenAI, set our API key, instantiate the client, and then we call client.images.generate, and you enter a prompt, size, quality, and n signifies how many images you would like to be returned. So what you get from this response object is a URL, and you access it through the first element of data's URL attribute. Then you can print this URL, okay, and it will print it. So, but what if we wanted to save it? To be able to save it, we need to import the requests library. We need the pillow library, which we need to pip install. I put it under requirements. This one. And we need the bytes.io, which is from IO, which is a standard Python library. So we can actually turn the image into a byte-like object. We first use the request with the image URL to actually get the image. And then we're using the bytes.io and image from pill. We turn it into a bytes object and image.save, cat.png. Actually, we can run this. When we run it, we're first going to get a URL, which we can actually take a look at the image at. Here we go. This is our URL. We can copy it or control click it. And this is the image that was generated. And the rest of the code was able to save it into cat.png. And we have it here now. So this is how you can use it. Both have the URL and save the images as well, like this. Over the past year, I've spent over 2,000 hours creating 200 plus free coding videos. If you want an easier time finding the content you're looking for, visit my website, www.echohive.live. You can search for the content you're looking for instantaneously. Also, you can find the code download links if you're a patron and read the descriptions as well. So continuing to GPT Vision. So the call to GPT Vision is exactly the same, client.chat.completions.create. We just use the model GPT-4 Vision Preview. We can still use streaming responses. Although so the idea is that we will be sending images to this API endpoint, but what we are going to be receiving is text in return. So we can use the same strategy to get streaming responses out of it. Now so that's why we set the streaming true, but there is a bit of differences here. So, normally our messages object is a list with a bunch of objects with roles, right? For example, the system role, the user role, assistant role. To make vision possible, now we have a list within the content of the user role as well. As you see, the content is now a list, and we have type. We have, again, inside of it, objects of type right? This is a type of text, and the text is of that is what you're sending, whatever you want to send to, right, to GPT. What's in this image, for example. And then the other type is image URL, and then you have to put in the image URL key. And in this case, we are going to be using a URL for an image. I have a control click this. This is the image. It said Wikimedia. This is the URL for it. So we're just actually asking what's in this image. When we run this, we should get streaming responses for it. The image shows a sweet natural landscape, narrow wooden boardwalk. So now we were able to send both text and some image at the same time. You can upload many images. Just remember that. You don't have to upload one image at a time. I'm not sure what the limit is, but you can upload many images at the same time. I believe their sequence matters, but I'll find out more about it and make a more detailed video. So, but this is how we can use a URL with the vision model. But how about local images? Let's say we have this cat.png, right, which we have just generated. What if we wanted to use this one? We can actually do this. To be able to do it, so we need to convert the image into a byte-like object. That's why we're importing base64. Everything else remains the same, except we have a function called encode image, which is going to take in our file path and then turn it into a base64 encoding, just like this, and return that. Okay, this is what that function does. This is our image path, cat.png. Okay, convert it into base64 image. After that, everything is the same. We still have a role user with content list of type text and the text we want to send, and the type again of image URL, but this time we're sending data :image JPEG base64, and we enter our base64 image here. So this is the convention. This is the syntax. If we use this, we again get a very similar result. And we again have our streaming true. The image shows a close-up of a cat sitting comfortably on what appears to be a cushion or a seat. So this is really marvelous. There's so many things to play with, I guess, explore. I wanted to make this video, get you familiarized with the API. Hopefully you can start playing with it. But do remember that currently it's limited to 100 calls per day. That's for GPT-4 Turbo. And GPT Vision has another, like I said, they're separate. GPT Vision has 100 on its own per day, and GPT-4 Turbo have 100. Check your rate limits for Dall-E and what else. Your rate limits might be lower, I'm not sure. Mine is 100. Anyway, so this is GPT Vision. Now let's move on to text-to-speech. So let's take a look at a basic example. From what I've seen and tried it myself, this works incredibly well. So essentially we're going to send in some text and we're going to receive audio in return from the API. To do that here, this is an example from OpenAI's library documentation. We are importing path, so that this is specifying where we want to save the MP3 file. I'm sure there will be different ways of doing it. Before I continue any further, I've realized I am on Windows. If you're on Windows, you do need FFmpeg installed. Okay, so I put in a chat conversation I had with ChatGPT, which has pretty much the correct instructions, but I'll walk you through it real quick. You do have to go to this ffmpeg.org website. I've downloaded this one. Once you've downloaded, okay, you have to unzip it. After you've unzipped it, then you have to move this folder to any place you like in your computer. And what you need is this bin folder. You need to get the path of this bin folder because you're going to edit into your path environment variable. Then search for your system environment variables. Go there. I did just type in env and click on edit environment variables. You have to click on these environment variables. I'm not going to do that now. I don't want to expose my API keys and reset them and whatnot. But once you click here, you're going to see two sections. The top section is where I put my API keys. Those are the user environment variables. And at the bottom, there's going to be a list of stuff. And one of them is going to be path. You have to go click on path and click on, I believe, edit. And then you're going to see a bunch of paths there. You have to paste this path, right? The bin, wherever you put in your FFmpeg folder, you need to get the full path of the bin. And then you have to put it in your environment variables, path environment variable. You have to find the path, edit it, make a new one, paste it in there, and then apply, close out of it by saying OK, and then restart your IDE Visual Studio Code, and you should be good to go. This is the download link. If you have any issues, just go to this link, and those are, I believe, correct instructions. I followed those. That being said, we have two models which we can use. TTS stands for text-to-speech. TTS1 is the cheaper, faster model, and TTS1 HD you can use also. There's also 6 voices: Alloy, Echo, Fable, Onyx, Nova, and Shimmer. Feel free to try each and every one of them. Today is a wonderful day to build something people love. So it takes in a model, voice, and input. Then response that to stream to a file will actually take that file path, and I will write it to that speech.mp3. It's done. You can go ahead and play it.
Today is a wonderful day to build something people love.
Indeed it is. So this is how it's done, right? This is the basic version. Don't forget FFmpeg. And then we can also stream the audio and play it while it's streaming. To be able to do that, you need PyDub, and you need to pip install PyDub. After you've done that, you need the audio segment and play from PyDub as signified here, and you also need IO. IO is a standard Python library. So essentially, we're just getting a response, just as we have done before, but now we are getting the response that so convert the binary response content to byte stream by using bytes.io, io.bytes.io. Now we have a byte stream. Then we use the audio segment from PyDub to actually read the audio data from the byte stream because it's an MP3 format, and then play the audio. Now when you run the script and this text input is going to run, then the stream and play function is going to run to play it. However, I ran into a few hiccups here. I'll show you what it is. The API works just well, but I'm getting this permission denied error, and I'm not sure why I'm getting it. I tried running my IDE in administrative mode. I couldn't overcome this. When I do, of course, I will make a more detailed video combining all these different ideas into one. But anyway, this is how you do streaming responses, okay? Now, last but not least, we have the assistants. I wasn't able to get assistants. First of all, assistant uses what's called run, and a lot of the runs currently are failing because the API is very, very busy. I'll actually show you real quick. So let me go to my playground. Assistants, threads, yeah. You create threads, so every thread you create, whether on the playground or in code, will show up here, and I'll just show you what I mean. See, run failed. So when the run fails, then obviously you don't get anything in return. But I'll try to walk you through what's going on here, because it's really interesting. So again, we are instantiating OpenAI, right? So now we have this client.files.create. So this is just a path to some CSV file, which is a bogus CSV file I've created. And purpose assistance, right? You create a file. When you do that, actually it shows up in your files. See, I've tried it many, many times. Each time it creates a new file. You do have a file limit, I believe, by like 1 terabyte or something like that. I'm not sure. So you do want to maybe delete them. You can delete them here. You can delete them programmatically. But everything you do here with assistance will show up here. So you can actually monitor what's going on. And also every assistant you create will show up here as well, okay? Wouldn't it be lovely if the ones you create here and the visual UI will show up on your IDE as well? Maybe that day will come, so maybe by copy paste. Anyway, but when you instantiate an agent, it shows up in your playground. Remember that. You can actually modify some of the things here, but I mean, obviously, if you modify it here, it's not going to reflect back. On the code itself. So you can upload files. This is fantastic. And you can actually also define tools. For example, code interpreter, browser, and retrieval. Here in this case, we're only using code interpreter. So anyway, let's not get ahead of ourselves. So we can upload files, and then we use client.beta.assistants create. So you give it a name, a description, right? Kind of like an instruction, like a system message. You do use GPT-4 1106 preview, and you select your tools and file IDs. Because we have uploaded our file, now we know this. We have this variable, and it is an ID, file.id attribute. So you assign that, okay? Or if you had multiple files, you would do the same, I believe. See, this is a list. Now, if you go to the UI, it's very similar, right? You have the name, instructions, you select your model, you have your functions, you have the code interpreter, retrieval. Sorry, I did say browsing before, right? We do not have browsing yet. I'm sure they'll add it at some point. So this code interpreter, retrieval, and functions reflect here, right? Under tools. And if you had any additional tools, custom tools like functions, you would add them here as function descriptions as well. Okay, just like this. Add. See, you would just like, sorry, you would add it just like that, because it's a list of objects, right? So type is code interpreter. I believe when you're specifying function call, you do say a function. I'm not 100% sure there, but this is where you define your tools and function calls. That's it. So you create an assistant, but this doesn't really do anything. You have to then start a thread, or I should say you can start a thread. And the way you start that thread is client.beta threads create. So it seems to me that threads are independent of the assistants. I'm not sure. See, we do pass in the file ID here, but I'm not sure how we know exactly that this thread belongs to this assistant. Nevertheless, this works, and we pass in the file ID along with our messages if we wanted to. That is, we didn't particularly have to, I believe. And then we use the run method, client.beta threads.runs.create, and we give it the thread ID and assistant ID. I see. Okay, now you see you're creating a thread, but we haven't used it yet, right? So we created an assistant, we created a thread, but we have not used it. This is run is where we bring it together. We say, here's my thread, here's my assistant ID. So when you run something like this, this is the object you get in return. So as you see that you get created at, you get run IDs, all kinds of IDs, thread ID. You also get a status. So status can be, I'm not sure, running or something, pending, completed, or failed. Okay. So what you need to do is you start a run of a thread, right, using an assistant and a thread ID. And after each time, you have to continuously check the status. And you do that by using the .retrieve. So to create a thread here, we use like runs.create. Here we are using runs.retrieve, okay? And we are checking run.status. As long as it's not equal to completed, we're gonna wait 1 second and continually check with the thread ID and the run ID and check. And if it has failed, we're gonna break it. This is what has been happening to me. So we break if the run.status is failed. If it is completed, then we break out of this loop, okay? And then we do move on and we say if the run.status is completed, we print run.completed. And then we get retrieve the messages object, clients.beta.threads.messages list thread ID. So we do have to pass in the ID. Now we have the messages. I do want to apologize because the runs are returning failed most of the time. I wasn't able to test this code in its entirety, but I'm pretty confident that this is 95% correct. At least I'm a little bit unsure from the portion that is coming right after this, right? So this is how we retrieve the messages, and we can print the contents of the messages. And I was hoping that I can receive the message content by message.content and annotations and whatnot with annotations. Now, what this whole annotation situation is I believe, you know how when you are when you're using code interpreter or something, like, it gives you it creates some file for you to download and stuff like that. This is what it means, I believe. So you can get the annotations and footnote by enumerating over annotations once you retrieve them from the messages, because messages contain actual message and annotations. So you index and annotation, enumerating over annotations, we get message content.value from message content.value, replace annotation text index. So it's difficult to know what's going on here without running and seeing what's happening here. I'll make more detailed videos, but we check if file citation, we get the cited file, and then we append it to citations. Here we had initialized it, and otherwise we create a click here to download option. And add footnotes to the end of the messages before displaying to user, message content.value. we add the citations, and then we print the message content. So, I mean, why is this important? I mean, because this is a general overview of how Assistance API is going to work. Essentially, you're giving it a name, description, choose a model, give it some tools, give it some files, create a thread. Thread is managed automatically by the API. You don't have to worry about dropping messages and whatnot. So they've implemented some smart strategies to keep it going indefinitely. You don't have to worry about summarizing earlier conversations or anything like that. And then you have to instantiate, create a run, and then continually check on the status of the run. Okay, status that can, so the run can fail, complete, or be pending, right? Running. So if it is completed, then you do all your other tasks. Okay. So this is it. I hope you enjoyed it. I hope this is helpful. So quite a lot has been unleashed on us today, right, as developers. So I think it's going to be a very exciting few weeks, few months. I hope OpenAI will be able to lift the 100 calls per day limit so we can all experiment to our heart's content. So thank you for watching. Please do let me know if you have any questions. I'll try to answer them as best as I can. Please leave them in the comments or join the Discord. Link will be in the description if you like to talk about large language models. Like I said, this Everything GPT API course is available. It's ever growing. I'm going to add more content to it. Link will be in the description. Each and every file has an associated video, whether it's the older OpenAI library or the newer one. I hope you'll find it useful. Thank you for watching, and see you in the next one.